So to continue our discussion of factoring, we can factor the GCF. If we have 4 or more terms, we can factor by grouping. And then there are some special factoring cases. So when it comes to binomials, which are polynomials that only have 2 terms, besides factoring a GCF off of our binomials, there's only a few special cases in which they factor. This is when you have a difference of squares, a sum of squares, or a difference of cubes. And I will show you what they look like with a few examples. So the difference of squares is when we have something squared minus something squared. It's literally the difference, subtraction of 2 squares. Okay, this factors to the sum of these 2 things times the difference of these 2 things. Okay, this difference of squares is actually just like that conjugates that we worked with when we were rationalizing the denominator. Basically, 2 conjugates become a difference of squares. Okay, so I've got a couple examples here. If you have 9x squared minus 16, that's a difference of squares, right? 9x squared is the same thing as 3x all squared. And 16 is 4 squared. So that factors to 3x plus 4 times 3x minus 4. We can do the same thing with a 4x squared minus 81y squared. But remember, the entire term has to be a square. So that 4x squared is actually a 2x all squared. Okay. So when you see binomials, check, are each of the 2 terms perfect squares, in which case you can factor them as a difference of squares. If they are sums, if it's a square plus another square, that does not factor. Only a difference of squares factors, not a sum of squares. But when it comes to cubes, we can factor a sum of cubes and a difference of cubes. All right, so if we have 2 terms added together and they are both perfect cubes, then they will factor to the sum of the 2 cubes times this kind of cross product of what's left. And if they are a difference of 2 cubes, they will also factor to the difference of the 2 cubes cross product. Okay. So take some time. You might want to multiply through this a minus, say multiply through the a plus b times a squared minus ab plus b squared to see that you get this a to the 3rd plus b to the 3rd. And similarly, in the difference of cubes, you may want to multiply through to understand how you get this difference of cubes. Here's another example of a sum of cubes. And here's another example of a difference of cubes if you want to look over those. Here's another sum of cubes. So those 2 terms, when you have a binomial, you can have the difference of squares, the difference of cubes, or the sum of cubes. And those are really the only situations in which we can factor a binomial. Another special case is when we have a trinomial that factors to a perfect square. We call that a perfect square trinomial. Essentially, what that is if we had a binomial and squared it, we would get this trinomial that happens to fold back together into a perfect square. You don't always have to recognize these trinomials as perfect square trinomials. Because when you go to factor them using some trinomial factoring techniques I'm going to show you, you will realize that both the factors are identical, which is what makes them a perfect square. So now let's talk about some of those techniques for factoring trinomials, specifically a quadratic trinomial, which is where we have a 2nd degree polynomial. So we have a squared term, a linear term, and a constant term. Okay. In this case, to factor these, we notice that our leading coefficient is 1, right? The coefficient on our x squared term factors to two linear factors. And all we need to do to figure out what those factors are is to kind of reverse what would happen if we had a binomial times another binomial. How would we get this? Basically, we need to find two numbers that multiply to our constant term and add to the coefficient on our x term. And then we can just write these as our linear factors. So for example, we've got x squared plus x minus 12. So our b is 1 and our c is negative 12. So if we want to figure out what are two numbers that multiply to negative 12 and add to 1, well, if they multiply to a negative number, they both need to be negative. Or sorry, one of them needs to be negative, one of them needs to be positive. And if to 1, then the positive number is just one bigger than the negative number. So the two numbers are negative 3 and positive 4, and they become these two linear factors just like this. You can go ahead and multiply through x minus 3 times x plus 4, and you'll see that it becomes x squared plus x minus 12. So that is factoring the quadratic trinomial when the leading coefficient is 1. It's fairly simple. You guys probably already know how to do that. What about when the leading coefficient isn't 1? When the leading coefficient isn't 1, we have to factor by grouping. Basically, we're going to break up that center term, that bx term, into two pieces that will allow us to factor by grouping. Okay. So in this case, we've got 6x squared plus 17x plus 5. What we want to do is break up that 17x into something that adds to 17x, like 10x plus 7x. But we want those two pieces to specifically factor by grouping with our 6x squared and with our 5x. So we want to find numbers that multiply to a times c, meaning two numbers that multiply to 6 times 5, but that add to b, so that add to 17. Because they have to add to 17 so that we can split our 17 into the sum of these two numbers. But we want them to multiply to a times c so that they're a factor of a and a factor of c, so that we can factor by grouping. So take a look and notice that 6 times 5 is 30. All right, so we need two numbers that multiply to 30, but they have to add to 17. So that's going to be 15 and 2. 15 and 2 add to 17, and they multiply to 30. So we can break our 17 up into a 15 plus a 2, which is okay because 15 plus 2 equals 17. And now we've got 4 terms here, and we can factor by grouping. So we'll factor the 16x squared plus 15x, and we'll factor the 2x plus the 5. Notice that the common factor is 3x amongst our first two terms, and the common factor is just 1 amongst our second two terms. But look at how nicely this works out. Our first term has a factor of 2x plus 5, and our second term has a factor of 2x plus 5. So we can factor out that 2x plus 5, and we get a 3x plus 1 times 2x plus 5. Those are the two linear factors of this quadratic. Okay. So that's factoring when your constant term does not, your leading coefficient does not equal 1. You really want to make sure that you know how to do this because you're going to have a lot of polynomials, a lot of quadratics that have a leading coefficient that is not 1. Okay. So let's do a couple more factorings that are a little odd. Let's say we've got a fractional exponent and we want to try to factor this polynomial. The technique when you have weird stuff like this is to factor out a GCF that contains the fractional factors. Notice that these are all x to some third. So we can pull out that x to the negative 2/3. All right, by pulling out that x to the negative 2/3 and also a factor of 3 as the GCF, notice the powers of x that we are left with. Okay. It takes a second to see that if we factor out a negative 2/3 from here, we end up with a full power of x, okay? Then from there, we can factor the remaining quadratic. Here's another example with fractional exponents. We've got a positive 1/2 and a negative 1/2 exponent. Same thing, we will factor out that negative 1/2 and we are left with this. Here's some general guidelines for factoring polynomials of all types. First, factor out the GCF, okay? Factor out a GCF, take a look at that leading coefficient, and if there's any negative numbers that you want to factor out as well to make your numbers positive, you can do that, all right? Then ask yourself, how many terms do you have? If you have 2 terms, you're going to need one of those special cases, okay? Either the difference of squares, the sum of cubes, or the difference of cubes, okay? If you have 3 terms, say, is this a perfect square trinomial? Use the trial and error method if your leading coefficient is a 1. That's just where we find the 2 numbers that multiply to C and add to B. And if our leading coefficient is not a 1, then we're going to have to use that grouping method where we split our middle term into those 2 pieces and factor by grouping. If you have 4 terms, you need to group them into terms with common factors and again, factor by grouping, okay? When you're finally done, make sure that you check everything, okay? And that your product is the original expression. If you want to come back to this slide, you can. Here on the right, I've kind of broken down some more of the steps, right? That is the end of this section. Good luck on your homework. Come back to any slides you might need later.